All right, so we're starting off with just graphing on the Cartesian coordinate plane. So this is just a graphing exercise. Number one here, right? Basically on the Cartesian coordinate plane, every point is x, y, and this is kind of the horizontal unit, and this is the vertical component, the y value, and so in the horizontal component, there's only two things you really need to know. So left is associated with negative values. And right would be associated with positive values. So these are the orientations that we have. And for vertical, up is going to be positive and down is going to be negative. So for the vertical, it's so hard to know how this works. As we said, down is negative. And up is positive. So for this one, we're plotting 6, 9. That means we're going to go 6 units to the right and then 9 units up. So, here and then go up 9, which is right here. You can make this a bit bigger if you want, but that should be 6, 9. So we check our answer, all set. Then same thing here. So negative 4, 1 is telling us go left 4 and then up 1. So we go to negative 4 and then up 1. And again, that one's all set. Sometimes this is also known as the Cartesian coordinate plane, after its inventor, René Descartes. He's a French mathematician and philosopher. Okay, number 3 here is just plugging in values. So number 3, a lot of times when you're graphing curves where you don't know what they look like, what you do is you plot a bunch of different x values to create ordered pairs until you get some reasonable shape of the curve. So here we have y equals x squared minus 9. So if you've got x and then y that you're trying to figure out, if you've got negative 3, as is listed here, then what you want to do is negative 3 quantity squared minus 9, which ends up as positive 9 minus 9, so that comes out to 0. So our ordered pair there is negative 3, 0, if we're going to graph it. So they do this with a bunch of these points. This is a parabola, so you might already have a guess as to its shape. So then we have negative 2, which is negative 2 squared minus 9. So that will come out to negative 5, 4 minus 9. So we have negative 5. And then we continue. So negative 1 is the next value. That's negative 1 squared minus 9, which is 1 minus 9, which is negative 8. And then we have 0. 0 squared minus 9 is negative 9. So that's our value there. And then all the positive values are going to turn out the same, right? Because whether you square a positive number or a negative number, you're going to get the same value. So 1 minus 9 is going to come out to negative 8 again. 2 minus 9 is going to be 2 squared minus 9 is going to be negative 5. And then 3 squared minus 9 is going to be 0. So we have our values there. And you can basically see that we're plotting them all. You can look at the graphs. X squared minus 9 is going to be graph C here. You can see the points kind of clearly. You have negative 3, 0 hitting the x-axis, 3, 0 hitting the x-axis, and then you have your y-intercept of 0, negative 9. You don't see that for any of the 3 other graphs, right? None of the other 3 satisfy those points. The closest is A, that has both x-intercepts, but its y-intercept is at 0, 9 rather than 0, -9. This viewing rectangle question is kind of dumb. It's more pertinent if you're used to working with a graphing calculator, which, obviously I think Desmos is a better resource for graphing, which is just an internet website. But what's going on here is for number 4, this is kind of like a window measurement. So what's going on here is we have first the x coordinates. So this is the x min value, x max value, and then the x step size. And then the second the second triplet there is the y min, the y max, and then the y step size. So it's telling us when I look at -50, 50, 10 that in the horizontal direction I'm going from -50 up to +50, and it's making a mark every 10 units. So I should, to the left of my y-axis, see 5 marks, and to the right of my y-axis I should see 5 marks. Does that make sense? So the one that looks like it's doing that, the only one that looks like it's doing that is A. And then also if you look at the y measurements, you should see 3 marks below and 8 marks above, which is exactly what you see, right? Because y is going from -30 to 80 with tick marks made every 10 units. So that's why this one looks like B right here. Sorry, A. A is the correct choice. That's the one we're looking at. So that one won't really come up too often for us in terms of tools, but if you are using a graphing calculator, if you click the window button on a graphing calculator, a lot of times it's going to have that sort of thing. I think if you go to like Desmos, and say we want to go to their graphing calculator. Let's say we were graphing something like the previous one, y = x squared - 9. It has like a default square of 10 by 10, but if you go up here to the little wrench, it allows you to change the graph settings. And it's essentially doing the same thing. If you notice, there's an x-axis from -10 to 10, and then there's a step, and then there's a y-axis of -14.52 to 14.52 in a step. So you could enter the same sorts of things here to alter the window. So the one we just saw was -50. Oh, I'm sorry, I put 2 negatives there. -50 up to +50 with a step size of 10. And then you could make the y. We were -30 to 80. And it also had a step size of 10. So then when you look at the graph, we're seeing that sort of thing. I don't know why it's not showing all the way up to 80. It doesn't have it quite in the right window, but you see the marks made every 10 units in both directions. All right, so back to the next problem. Okay, so this one's pretty straightforward. X-intercepts just means where is it hitting the x-axis, and y-intercepts means where is it hitting the y-axis, right? So we're looking at this graph here. It first asks us where are the x-intercepts. It touches the, and you can make the graph a little bit bigger if you want. It touches the x-axis at 5, and it touches the y-axis at 1. So your x-intercept is going to be 5, your y-intercept is going to be 1. So for part A, we would say, okay, our x-intercept is 5. And our y-intercept is going to be 1. And that's it for that. Okay, this one So there's two features to this word problem. You have formulas that are modeling the percentage of alcohol and marijuana use, and then you also have the graph that gives the exact values. So you've got a model that tries to estimate it, then you have the actual numbers put on the graph. So for part A, it says, use the line graph to determine the percentage of seniors who use marijuana. So marijuana is this, I'm colorblind, so I don't know. Is that a different color? This one's blue, I know. Is that purple? Yeah. Okay, so that one's purple. So we're using the purple graph to try and find what that value was in 1990. So if you look at 1990, the purple graph looks like it's hitting 10 in 1990. So we would type 10 there. And then it says, use the formula to determine how much marijuana use there was. So what is the formula estimating? So the formula first for the marijuana use is negative 0.5 N plus 26. And it's important to note that N is years since 1980. Okay, so when they ask marijuana use in 1990, we are going to plug 10 in where N is, because it's 10 years after 1980. So we go ahead and do that. M is negative 0.5 times 10 plus 26, so that comes out to 21. Negative 5 plus 26. So we're getting something that's quite a bit off there, not a very good estimate to the true value. But it does appear that there's a little dip there, so that might be the spot where you're going to be most inaccurate. Okay, so the formula is overestimating because it's picking a higher value, 21 versus 10, and it's overestimating by 11%, the difference between the two. Okay, so then they're asking for the same thing, but now we're using the alcohol graph and the alcohol formula. So in 1990, alcohol was, it looks to be about 60%. It might actually be a touch under. Yeah, it looks a touch under. That maybe looks like closer to 58, so I'll try 58. Okay, so 58 is a good choice. Then it says use the formula. So for this one, our alcohol is negative 0.9 times N plus 62. So for the alcohol value in 1990, again, N is still going to be 10. So that one's coming out to 53, which is quite a bit closer than we saw for the marijuana estimate for the same year. Okay, so this was an underestimate by 5%, because it's picking a lower value. Okay, so then they're saying from 1980 through 2009, which year was marijuana use maximum, and estimate the percentage in that year. So it looks like it's highest right there in 1980, the initial year. And again, maybe you want to make the graph bigger. I would say maybe 32% here. And that's it for that question. You just have to know whether you're looking at the graph or whether you're using a formula. That's usually the only thing that trips people up. Okay, so then we're solving linear equations. These are quite a bit easier than some of the other things we were doing, in my opinion, on the prerequisite material. Again, that's all you're trying to do is isolate the x term first and then divide by the appropriate number so that there's no number in front of x, right? So if we have 5x minus 10 equals 0, the first thing we want to do is get the 5x thing by itself, that term. So we start by adding 10. And you have to do the same thing to both sides of the equation to maintain the equality. So we have 5x is equal to 10. and then we divide both sides by 5, and we're left with the answer x equals 2. So one thing that I do see students the first time they start encountering the solution set notation, this x equals 2 answer, normally you would stop here if you were just doing it on paper, but this corresponds to saying the solution set is 2. So 2 is just all the numbers that would work in the equation. So the mistake I see sometimes made is inside these two squiggly braces, someone might type x equals 2, and it'll mark it wrong. You're just supposed to type 2 there. Okay, so that's one thing to keep in mind. Okay, and then this next one is not any more difficult. It just requires a little more unwinding. So we're going to do the same thing where we want to get x's on one side and regular numbers on the other, but we have to do a little distributive law on two parts of the equation to remove the parentheses, right? Now that we have variables, we can't just combine what's in the parentheses. The only way to get rid of those parentheses is to use the distributive law. So 3 times x is 3x. 3 times negative 3 is minus 9 plus 14. And then distribute on the right-hand side of the equation as well. So we do 2 times x, which is 2x plus 2 times 5. Okay, so the negative 9 plus the 14 can be combined on the left. So we have 3x plus 5, and that will equal 2x plus 10. Okay, so then you have to make a decision about what side you want to put the x's on. So the better choice here is to subtract 2x. Then you'll just be left with positive x on the left-hand side. So you can kind of do this part in one step. You want to subtract 2x to move the x's around. So your x's will now end up on the left-hand side of the equation. But you also want your regular numbers to be on the opposite side. So the regular number that's on the left-hand side is 5. So to get rid of that, we're going to do minus 5 at the same time to both sides. So 3x minus 2x leaves you with x. The positive 5 and the negative 5 cancel out. And on the right-hand side, the 2x and the minus 2x add to 0. And 10 minus 5 will just add up to 5. So we have a answer of 5 on the right-hand side. Okay, for number 9 here, we're going to go through the same process. Again, we just need to distribute. Here we have some actual negatives to distribute. Remember, the negatives go to both terms as well as the number. So the first distributive part are 2 times the x minus 3. That's going to be 2x minus 6. For the second set of parentheses, we need to distribute the negative 3. So that's going to be negative 3x, and then negative 3 times negative 2 is plus 6. So we have minus 3x plus 6. The right-hand side, we just need to distribute the negative across the parentheses. So we just copy down x plus 2, and then we'll have a minus x, and the two negatives will make that a plus 3. So then we have some combining to do on both sides. 2x minus 3x is minus x. Our minus 6 and our plus 6 add up to 0. And on the right-hand side, x minus x cancels out, and 2 plus 3 is equal to 5. So what you want to do now is multiply or divide both sides by negative 1. So we end up with just x equals minus 5 as our answer. So the solution set here is minus 5. Okay, when you have a linear equation with a bunch of fractions, there's a nice trick so that you don't have to like add things and get common denominators. What you can do is you can multiply everything by a common multiple of the denominators, and then all the fractions will vanish until the last step. So number 10 here, there's a nice trick. Multiply by least common multiple of the denominators. to eliminate fractions. Usually this is more efficient than trying to get common denominators of all the fractions and mess around with those. So we have x plus 7 over 10, and this equals 8 over 5 plus x minus 4 over 6. We're looking at all three denominators, 10, 5, and 6, and we want a common multiple. So a number that all three of those divide into easily. So 30 would work, right? 10 goes into 30, 5 goes into 30, and 6 goes into 30. So we multiply both sides of the equation by 30. And then we're going to distribute, right? So on the left-hand side, 10 goes into 30 3 times, so we're left with 3 times x plus 7. On the right-hand side, 30 divided by 5 is 6, so we're left with 6 times 8. And then 30 divided by 6 is 5, so we're left with 5 times x minus 4. So now we're back to one of the types of linear equations we were just looking at in the previous examples. So we just distribute everything, combine like terms. So we have 3x plus 21, 6 times 8 is 48, and then this will be plus 5x minus 20. Okay, so 48 minus 20 is going to be 28, so we're left with 3x plus 21 equals 5x plus 28. And then we want to get the numbers on one side and the x's on the other side. So just to keep things simple, I typically like to leave the coefficient of x positive if I have a choice, if that makes sense. So here, since I have 5x and 3x, you want to subtract the smaller one. So I'm going to subtract 3x from both sides. That will move my x's to the right-hand side. So I subtract 3x. And then I want to move the 28 to the opposite side. Since my x's end up on the right-hand side, I want my numbers on the left. So I'm going to subtract 28 from both sides as well. So 21 minus 28 is negative 7. 5x minus 3x is 2x. And the 28 minus 28 is 0. So then I just need to divide by 2, and that's my answer. X is minus 7 over 2. Any questions there? This one looks kind of similar. Do you have your hand raised? Yes. Excuse me? Yeah, we can go through the question help if you have an example. And we can look at this problem. So, example, solve x plus 8 over 12 equals 5 over 6 plus x minus 1 over 5. So, in this case, we would go through the same routine. You want to look at 12, 5, and 6 and see what is a number that is a common multiple to all of those. You have any idea there? Common multiple of 12, 5, and 6. 30 doesn't work because 12 doesn't go into 30. So you might try 60. 60 would work. So we would do 60 on both sides of this time. So 60 times x plus 8 over 12. And then 60 times the 5 over 6 plus x minus 1 over 5. So divide 12 into 60, we're left with 5 times x plus 8. Then divide 6 into 60, that leaves you with 10 times the 5. Then you go 5 into 60, that will leave you with 12 times the x minus 1. So that's the crucial step, really. After that, it just turns back into one of the earlier problems. So we have 5x plus 40, and then that will equal 50 plus 12x minus 12. Combine the 50 minus 12, which comes out to 38. So we have 5x plus 40 will equal the 12x plus the 38. You could also write it as 38 plus 12x. I just like to keep the x's in front. That's typically the way you write the polynomials. You write the highest powers of x first, followed by the lower powers. That's just kind of the usual convention. Okay, so then we want to move our x's to the right, because 5 is smaller than 12. So I want to take away 5x. So my x's are going to the right-hand side, so I want to make the 38 go to the other side, the left. So I'm subtracting 38. So I'll be left with 2, and that'll equal 7x. So divide by 7, and we're done. So x is 2 over 7 in this example. So finding that common denominator. One thing you can do is you could actually multiply all three of them together, but a lot of times that will give you a much bigger number. So sometimes it's easier to try and find the least common multiple, because if you multiply them all together, usually what happens is you'll be left with a fraction that's not reduced. So in this example, our three numbers in the denominator were 5, 6, and 12. Well, if you multiply all those together, 5 times 6 is 30, and 30 times 12 is 360. So that would leave you with a much bigger, probably, denominator. You'd probably end up with stuff to cancel. So multiplying by 60 is a much smaller choice than multiplying both sides by 360. Oh, sorry, we're meant to go to the next one. Okay, so again, we are familiar with this from domains. The first question is, what are the values of the variable that make the denominator 0? Well, it's just x and 5x. And the only thing that would make that 0 is if x were 0, right? There's not like anything more complicated in the denominators. So x equals 0 would be an answer that would not make sense for this problem. And now we want to try and solve the problem the same way. We want to multiply both sides by the value of a common multiple of the denominator to clear it. So in this case, you have x and 5x. What you would want to multiply both sides by is 5x. That would be the common multiple of the denominators. That includes all the factors. So you have to think of x kind of like it's a prime value or something like that. So you have 3 over x equals 9 over 5x plus 2. So what you want to do is multiply both sides by 5x. So the x's will cancel on the left, and you'll just be left with 5 times 3. On the right, 5x will cancel with 5x here, so you'll get 9, and then you'll have to multiply 5x times 2. So this is the equation you're left with. 15 equals 9 plus 10x. So subtract 9 on both sides. And we're left with 6 equals 10x. And then we divide. So 6 over 10 is going to be our answer. Again, that's not in the lowest terms, right? They both have a factor of 2. So that can be reduced to 3 over 5. And it's not equal to 0. If it were equal to 0, that's not allowed from the original problem. So we would say the solution set were empty if it were 0, but it's not. So we just enter the answer that we got. Kind of works the same as the other one. You just have that first restriction where you have to make sure you're not causing division by 0. So this is going to be similar here. Your two denominators that you see are x plus 2. They're both the same. So you have to ask yourself, what number would you plug in for x that would make the denominator 0? And the answer here would be -2. negative 2 plus 2 would make the denominator 0. So the answer to that first question, what makes the denominator 0, the answer is negative 2. And then when we're multiplying to solve this one, we're going to multiply both sides by x plus 2. That's the only denominator available. So we have 4x over x plus 2 equals 2 minus 8 over x plus 2. So both sides get multiplied by the only denominator that exists, which is x plus 2. So the left-hand side, the x plus 2 cancels with the denominator. You only have 4x. On the right-hand side, well, you're going to have the x plus 2 times the 2. And then when you distribute it to the second term, it cancels with the denominator there, so you're left with a minus 8. So we can distribute that 2 to get rid of the only set of parentheses left. 2 times x is 2x. 2 times 2 is 4. And then we just have a relatively simple problem left. So we have 4x equals 2x minus 4. We want to move the 2x to the left. So we're left with 2x equals negative 4. And then if we divide by 2, we are left with x equals negative 2. But this is not actually part of the solution set, right? Remember, the first question was what x value was not allowed. And it was exactly x equal to negative 2. So this causes division by 0 in initial problem. So that's why we say the solution set is the empty set here. So that Greek letter phi, that represents the empty set, the set containing nothing. Okay, so getting back to some of the original equations, we haven't run into options B or C yet, so I'm thinking that those are going to come up. Remember, when you end up with something that doesn't make any sense, that's when it's a solution. It has no solutions, right? So if you do all the steps and you end up with something crazy like 5 equals 2, then that means the initial equation never makes any sense. You might have like a scenario where you're trying to set parallel lines equal to each other, and those would never have any intersection point. Or if you end up with something that's obviously true all the time, like say x plus 1 equals x plus 1, you could plug in any number for x and that equation is always going to be true. That's when you get option B. The solution set is any real number. So let's see if we end up with one of those possibilities here on problem number 13. So we have 3x plus 24 equals 8 times x plus 3 minus 5x. So we distribute that 8, and we end up with 8x plus 24 minus 5x. And then lo and behold, 3x plus 24 is equal to 3x plus 24. Well, you're doing the same thing to x on both sides, so it doesn't matter what number you plug in for x, you're always going to get those two sides equal. Right? If you plug in 0, you end up with 24 equals 24. If you plug in 1, you end up with 27 equals 27. No matter what number you plug in for x, you're always going to get equality. So basically, x is any real number. That's the solution set there. So B. So this is known as an identity. A conditional equation is just when you get a regular solution, and an inconsistent equation is one that has no solutions. So we have another one. So number 14. 10x plus 9 equals 7x plus 9. So normally what we do is we try and just move the x's to one side and the regular numbers to the other. So we'd say, okay, well, minus 7x and minus 7, 9 from both sides. So we end up with 3x equals 0. And this one is just x equals 0, right? You can divide both sides by 3, and x is equal to 0. Remember that if 0 is on the top of the fraction, that makes the fraction 0. If you see 0 on the bottom of a fraction, that's when the number's undefined. Sometimes people get mixed up and they think 0 on the bottom makes it 0, but it's when 0 is on the top. So this has the single solution, and that solution set is 0. This is known as a, again, terminology is not too important, but this is called a conditional equation. Okay, this is a word problem type linear equation. So you just have to get the variables right to plug things in. There's nothing too complicated about it. So you have this tuition equals 165 times x plus 2,771. And you want to look back in the problem to see what x means. X is years after 1996. T is the tuition. So they're asking, when will the tuition be 6,236 per year? So that's a t value they're giving you. So you would plug that into t, and then what you'd want to do is solve for x. So we get 6,236 is equal to 165x plus 2,271. So to solve for x, we just need to get the regular numbers on the left. So we're left with 165x equals, I don't know, 3,000. It's going to be 236 from that is 535. 465? 3,465? Is that right? Six 236 minus 2771. 3465. Okay, and then we want to divide that by 165, which is 21. So since x is years after 1996, that means tuition is 6,236 in 21 years after 1996 would be 2017. It sounds really low. I don't know. Okay, here's a word problem where you basically want to create your own variables and then go ahead and solve it. It's really not too difficult, but the important thing is to just stay organized. So for number 16, we've got two things going on here. We've got number of years sleeping and number of years watching TV. So let's let t equal number of years watching TV, and we'll let capital S be number of years sleeping. So then we'll read the problem, and the thing when you're reading these word problems is I always go to what they're asking for to figure out the variables. That's why, at the end it says how much will they spend on sleeping and how much will they spend on watching TV. That's how we constructed the variables. Then I try and go through a sentence at a time and see if I can write down an equation. So, according to statistics, a person will devote 32 years to sleeping and watching TV. Well, that's an equation. If you add the two together, you get 32. So we know S plus T is equal to 32. And then let's go to the next sentence. The number of years sleeping will exceed the number of years watching TV by 22. So that means sleeping is the bigger number. So if you add 22 to the TV number, you get S. Right? So this is telling me S is equal to T plus 22. Right? If sleeping is the bigger number and you add 22 to TV, they should be the same. So now what I can do is I can kind of combine these two equations. I can take S in the top equation and replace it by T plus 22. So I get T plus 22 plus T equals 32. Does everyone see how I did that? I just took the S, that was T plus 22, and replaced it up here. Because S is equal to T plus 22. And we can't solve an equation unless we get it down to one variable. So T plus T would make 2T. So we want to subtract 22. So we get 2T is equal to 10. And then divide both sides by 2. We get the number of years watching TV is 5. And then we also know that S is going to be 5 plus 22, which is 27. So we spend 5 years watching TV and 27 years sleeping. Any questions on that one? Just go through problem or line by line and write an equation. I think one of the mistakes people make when they read word problems is they read too much. So they try and read everything and put it in your brain all at once. So maybe if you're reading essays or something, it makes sense to read everything and then think about it. But usually for math problems, you want to kind of chunk them, go through piece by piece, and that makes things easier because there's a lot of stuff going on and it's hard for you to keep track of everything. So you just try and organize it in multiple equations and then find ways to synthesize that information. That is, combine it into one equation like we did here. So this is going to be another similar one. We're just going to come up with two variables and then see if we can write down two equations. So how much was invested at each rate? So basically we've got some big account with two amounts invested in it. So let's say X be the total amount invested at 7%, and Y be the amount invested at that second rate, 9%. Okay, then we just try and go through sentence by sentence and see if for each sentence we can write down an equation. So the first sentence says you invested $28,000 in two accounts playing 7 and 9%. So that's your total investment. So that's just saying X plus Y is equal to 28,000. So we got an equation from the first sentence. Then we go through to sentence number 2. If the total interest was 2020, how much was invested at each rate? Well, if we know the total interest, can we figure that out with the variables that we used? Well, how do you get interest? So if I told you I invested $100 at 5%, how would you figure out the interest? You multiply the amount invested by the percentage earned, right? The percentage yield. So you would earn $5, right? 100 times 0.05 gives you the amount. Well, we don't know how much we have invested as a number yet, but we do have a variable representing that amount. right? So instead of $100, we know X dollars is invested at 7%. So to figure out the interest from the X account, you would do 0.07, the yield, times the amount invested X. So we have 0.07 times X. Now we want to figure out the interest coming from the Y account. Well, that's 9%, so that's 0.09 times Y. And we know that the interest totals 2020. So that equals 2020. So now we have our two equations. So we just want to put them together and solve them somehow. So we could substitute. We could do it that way. Maybe that's the easier way. So let's take this top equation and maybe solve for X. So we know X is the same thing as 28,000 minus Y. And now we want to replace X in this equation with the 28,000 minus Y. So we know 0.07 times this 28,000 minus Y plus 0.09 times Y will equal 2020. Okay, so we've substituted. Now we have an equation that only has one variable in it, so we're going to be able to solve it. And 56. 96. So I think if we distribute, we get 1960 minus 0.07y plus 0.09y equals 2020. So we can combine the 0.07y and the 0.09y. That's going to come out to 0.02y. So we have 1960 plus 0.02y equals 2020. So now we just subtract 1960 from both sides. So 0.02y equals 60. And then divide by 0.02. So I think that comes out to, what, 3,000 or something? Yeah, 3,000. Did I do my first thing right? What was the one? 0.07 times 28,000. Okay, good. So y is 3,000. And remember that x plus y had to total 28,000. So that means x is the 28,000 minus the 3,000, which is 25,000. So we had 3,000 invested at 9% and 25,000 invested at 7%. So a little bit of a tricky problem there because we have some decimals to deal with, but you just want to rely on your calculator in those circumstances. So we had 25,000, 7%, and 3,000. That's 9%. Okay, so it looks like the end of these are quite a few word problems. So let's continue. Number 18. So we want to know the dimensions of a rectangular playing field. So, I mean, we have some picture here. We'll call this side X, and we'll call this side Y. Okay, so the length of a new rectangular playing field is 5 yards longer than quadruple the width. So one key thing to always look for is pretty much always means equals when it comes to equations. So if we call the length, let's say it's X, the length is X, it says that is 5 yards longer than quadruple the width. Well, if that would make the width Y, so 4 times Y is quadruple the width, and 5 yards longer would be plus 5. So we know X is 4Y plus 5. Let's look at the next sentence. If the perimeter of the rectangular field is 570, what are its dimensions? Well, perimeter is just twice the width plus twice the length, right? You're adding all 4 sides together. So 2x plus 2y, or 2l plus 2w if you're using L and W. So 2x plus 2y should equal 570. So again, we can just replace x in the second equation with this 4y plus 5 in parentheses. So we have 2 times 4y plus 5 plus 2y equals 570. See, so all of these word problems just reduce to one of these linear equations with some parentheses in it. So distribute the 2. We have 8y plus 10 plus 2y equals 570. 8y plus 2y are 10y. 10y plus 10 equals 570. We want to subtract 10 from both sides. That will leave us with 560. So 10y is 560. And then when we divide by 10, we'll just get y is 56. So y is 56. And then the length, x is 4y plus 5. So x is 4 times 56 plus 5, which is 229. So 56 yards is the width, the shorter side, and 229 is the length. Okay, formulas are pretty easy. We just follow the same types of steps, but we won't be able to combine things. So this one's saying solve for Q. So you first move anything that's added or subtracted to it to the other side, and then you divide by whatever it's being multiplied by. So for number 19 here, we have S equals W plus QR. So we want to get that W to the other side, so we subtract W from both sides. So we're just left with S minus W equals Q times R. We're trying to solve for Q. Q is being multiplied by R, therefore we divide by R. So it's the same steps you would have in a normal problem. They're just all letters, so you can't like simplify them the way you can with numbers. So S minus W over R is equal to Q. I think this is capital sensitive, so let me try it with lowercase letters and see if it tells me I'm wrong. So that's one thing to keep in mind. If it is capital sensitive, you need to make sure to distinguish uppercase S from lowercase s and so on. See, so they marked it wrong because this should be a capital S and a capital W. If you've ever done any programming, some computer languages are capital sensitive and others are not. So the advantage is if it's capital sensitive, you have more symbols that you can use, but the disadvantage is sometimes it's easier to make syntactical errors because our brain can associate them, especially when the lowercase and uppercase look similar. So this is capital sensitive. This one we want to solve for t. Same sort of thing going on. There are two factors being multiplied by t in this one. So that means we're going to have to divide by two things. But other than that, everything else is very similar. J equals m plus m rt. So this m on the outside is being added. We want to start by subtracting it. So j minus m is equal to m rt. And so t is being multiplied by m and r. So we need to divide both sides by both m and r. So j minus capital M over capital M times r is equal to t. That's it. Last one. This one is a little bit tricky. Why is it tricky? Well, we see b appearing in two places. So we have this a equals 2bc plus 2bd. Well, if b is in both places, we can't isolate it by adding and subtracting. But what can we do that we learned about in Module 2 if you have the same thing appearing in both terms? Yeah, so you can take it out. You can factor it out. So we put b, then a set of parentheses, and then everything that's left over from each term. So we're just using factoring. So we can do a, we can factor out the b, and then in our parentheses. So the first term, 2bc, if you take out the b, that's all that's going to be left is 2 times c. And then the second term, 2bd, if you take out the b, you're just left with 2d. Now b is being multiplied by everything in the parentheses, so we just divide both sides by everything in the parentheses. So we divide by 2c plus 2d. So a divided by this 2c plus 2d is equal to capital B. And that's it. Again, capital sensitive, so 2c plus 2d. So if you have that letter in multiple places, you have to factor. Okay, so let me stop the recording.